Hey guys, please copy this box down below. So if we have the nth root of a to the n, that's going to equal the absolute value of a when n is even. I'll explain that in our first example. And if we have the nth root of a to the n, it's just equal to plain old a when n is odd. This is just notation that's important to keep in mind. I'll explain that in our first example above. So here in example 2, simplify the expressions. Assume that all variables are positive real numbers. So here I have the fourth root of negative 3 to the fourth power. Now some might think that would cancel out and just make negative 3. But since I have an even power, I could break this down to be the fourth root of negative 1 to the fourth times 3 to the fourth. Now keep in mind, negative 1 to the fourth cancels and just becomes 1. So this is the fourth root of 3 to the fourth, which is 3. A positive number, not that original negative 3. So if we memorize that initial property that I showed you in that box, keeping in mind that that even power will cancel out the negative and leave the positive, we always take the absolute value. Okay. So now let's keep it going. In part B though, now I have an odd root of an odd power. Those just cancel out to leave negative 3. Now here I have an even root of an even power. That's going to be the absolute value of x plus 2. Here an odd root of an odd power is just a plus b, not an absolute value. Here square root of a fourth power, that is going to be the absolute value of y squared, which is kind of redundant, we get it. All right, here the square root, the even root of 4, is going to be the absolute value of negative 4, which is 4. Here the cube root of the cube of negative 6 will just be negative 6. The fourth root of v to the 8, fourth root dividing into that makes absolute value of v squared. So whatever my index is, I divide into that exponent to get my new exponent. Think of that shortcut. So let's see, the cube root of 27 is 3. The cube root of a to the third is a. Here, the fifth root of a to the fifth is a. The fifth root of b to the 10th, 5 into 10 is b squared. All right, here I see my answer is going to be negative. Let's see, the fourth root of 81 is 3. The fourth root of x to the fourth is x. The fourth root of y to the 8th is y squared. And the fourth root of 16 is 2. All right, here we go. Cube root of m to the third is m. Cube root of n to the 6th is n squared. Cube root of o to the 12th is o to the 4th. I'm dividing in. Here, the square root of t to the 6th is going to be the absolute value. Ooh, why am I putting y? The absolute value of t to the third. Because t to the third could be positive or negative, so that's why it's so important to put the absolute value on that one. And now here, the fifth root of 32 is 2, and the fifth root of m to the 25th is m to the 5th. So you see, simplifying roots, as long as you know these properties, pretty simple. We'll practice this 7.1 Miller tomorrow.